Welcome back to Wireless LAN Professionals podcast. Today I have with me Jerry Olla. Jerry, how are you?
Hey Keith, yeah, doing fantastic. Hanging out here with my buddy UC in Florida.
In Florida, you guys are at Bixby, right?
Yeah, we just actually wrapped up the Bixie event here and catching up on some things here before heading home.
Did you convince them all to do Wi-Fi correctly?
Yeah, I think we made some progress. What do you think, UC?
Yeah, for sure. Hey, everybody. Hey, Keith. Good to hear from you again. Yeah, we did have a speaker slot where we talked to like more than 100 people there about Wi-Fi. Then we had a speaker slot, which was funny because so 30 minutes before the speak, I told Jerry that you should come on stage with me, and he was like, "Well, I've never seen your presentation. I have no idea what you're going to talk about," and that made it even better. We just tag teamed it, and it was awesome. And it was full room, hundreds of people, standing room only. People had to stand at the back. So I think it was well received. Jerry did an awesome job. So he kind of brought the real expertise into the house.
Try to balance things out, right?
Exactly.
So he was the counterpoint to your humor.
To my marketing spiel. Exactly.
Hey, it's like, and UC said this, but let me tell you how it really works.
like as Keith always says about me, he's a VP, so he doesn't understand technology, right?
Oh, I know you understand it. It's just fun to tease you. Well, onto this podcast today. Thanks for kicking in there, UC. With Jerry, years ago, it was actually before you were with Ekahau. We were at a conference, I think it was in Minneapolis.
That's right.
And with Blake, and you had this cool little toy that you showed off of how to do some testing. Blake and I and a couple others kind of followed along with what you did, and it turned into something we put at WLPC in Budapest, and we've tried them across. And the next WLPC, we've got a new little better, cooler one. I thought it'd be a good chance for our audience to listen in and kind of hear the history of how Jerry developed this whole thing. I mean, this is your baby, and it's come a long way. So you good with that?
Yeah, absolutely. That was a good reminder of. I totally forgot about that event, and that was definitely a big step in the right direction of the small portable throughput testing device, and that's really where that whole thing was born from. Was trying to come up with just had this kind of project where I was previously working at a company doing a lot of stuff with voice over Wi-Fi type deployments, and anybody that's worked with voice over Wi-Fi knows the challenges that are associated with that, and just testing the readiness of a network for voice over Wi-Fi and the resiliency of the network to make sure that it was going to support that type of traffic. And needed to be able to go to different sites and be able to quickly just deploy this throughput testing device that could test the throughput, but also the consistency of the network. So measuring things, particularly like jitter on the network to see, was the network, fluctuating, going fast, slow, or was it, running at a consistent speed, end to end, right? Not just the Wi-Fi, but also testing the wired piece where the head end of the voice server would be.
So you could have used just a laptop running iPerf or something on one end. What made you think of not, that's the first thing most of us would think about is get out my spare laptop and attach it someplace.
Yeah, absolutely. Yeah, so certainly could have. I wanted, I was traveling a lot. So anybody that's doing, Wi-Fi surveys and stuff, I'm sure can relate. The smaller we can come up with things and battery powered and things like that. That's always what I had in mind and looked for. So lugging around a second laptop wasn't going to be a good solution to, be lugging onto a plane and things like that and having to keep another laptop charged and carrying around another charger. So I wanted to come up with a really portable, really lightweight solution, one, so that I could travel around with it, but two, occasionally I needed to move this thing around to different parts of the network. So being able to just have the battery powered, be able to unplug it from maybe one switch and plug it into another switch in a different part of the network or different building, made it really, that's really what I was after, right?
So did you think of a little, Raspberry Pi as a alternative?
Briefly looked at a Raspberry Pi and then quickly realized that was not the right solution for a real, true, robust throughput testing device, because of the biggest limitation on the Raspberry Pi is the Ethernet port is a 10100 only Ethernet port. So you're going to have a big bottleneck there if you really want to kind of drag race test an 802.11 AC network. and see what the speed is. That's going to be a bottleneck for you. For jitter, that kind of thing, yeah, it would have worked fine for just being able to test, certain things. But yeah, it's not going to be the ideal solution for that.
So what was the single board computer you went with instead?
Yeah, so it even back up a little bit further. Before the Odroid, I did kick around a couple other pieces of hardware. The very first one that I actually used was actually a open source wireless router that was just a consumer grade and had a couple gigabit Ethernet ports on there. And it was open source, so it was running like an embedded Linux on there, and I was able to use that to run like an iPerf server, but it was just really difficult to work with, really limited on what Linux versions it would support and what packages I could install. And
was it like regular Linux or was it more like a WRT?
Exactly. Yeah, it was a DDWRT firmware that I was running on there. So yeah, you were really limited of which versions the hardware would support, right? So yeah, that, and the other thing was it was a little bigger, because it was a wireless router, and then you couldn't really battery power it, and it had to have like a brick charger for it. So it had, it was still a decent size. It wasn't really much more convenient than lugging around an extra laptop, like you said.
And then?
Yeah, and then discovered the Odroid. So actually, kicked around a couple of different single board computers. Prior to that, not really worth probably mentioning the other ones because they just weren't very good for support and Linux support. So yeah, ended up finding the Odroid made by Hard Kernel, and had really good support from the community. Not as vast as like the Raspberry Pi community is, but good enough for my purposes of supporting different Linux kernels and up to date, and all the packages and things like that. So works with like the Debian and Ubuntu distros. It really satisfied all the checked all the boxes, right, that I needed. It was a nice same form factor as the Raspberry Pi, so nice and small and really low power, so it could be easily powered by a battery.
And how did it test out from a throughput standpoint? I mean, was it the bottleneck, or could it outrun your Wi-Fi?
Yeah, good question. So yeah, that was the other factor, was a couple of the other single board computers that I did try out that were similar form factors would max out just because of the pure kind of horsepower of the hardware. Just couldn't handle, more than maybe like 500-600 megabits per second. And the hard kernel, the Odroid C2 that we used, that one could easily do over 900 megabits a second of up and down. So yeah, really could saturate the whole gigabit Ethernet connection.
And Odroid had some others that are even more powerful, but then they draw more power.
Exactly. Yeah, it was kind of the perfect balance, right, of size, horsepower that it had capable of processing, but then didn't draw very much power. So really met all the needs, and then had plenty of options of accessories. Like an LCD screen and different cases, and ways that we could kind of configure that for the throughput testing device needs.
So in the process of doing throughput testing, and the first time I saw you had one of these, it was kind of difficult to figure out. It's headless at that time, yep. Meaning there was no screen at all. And so to figure out what your IP address was, so you could have control over it, what was the process you had to go through in that first cycle?
That definitely was the pain point up until then. Was everything that I had been doing was all headless. So you'd plug it into a network, and either you'd have to statically configure an IP on there and then hopefully be able to route to that IP address, or you'd have to grab a DHCP address and then kind of have to reverse engineer it of going to your DHCP server and plugging in the MAC address and looking up that IP address, or using some type of IP scanner. It wasn't, a pretty process, and wasn't consistent, from that standpoint, right? So that wasn't from a user standpoint very ideal. So we had to figure out a good solution to that, of telling us what its IP address was. I did play around with once. I don't know if I ever showed you this. One of the initial things I kicked around was actually an email script. It was a Python script that I had found and kind of reversed for this. Was when it would grab an IP address, it would actually email me what its IP address was, which, filled that gap a little bit. But the problem is that means what you were plugging the Odroid into needed to be able to route to the internet, right, to be able to send me an email. And that wasn't always an option for me in some of these, customer settings and things like that, where I was plugging into their network. some of these voice only networks didn't need to route to the internet. So that kind of shot that one in the foot pretty quickly.
And another issue that we ran across in Budapest that obviously has been solved since then was the idea that, we should get a bigger memory card, because if you have a bigger memory card, you can save lots of data. And there was no way at the time, and even talking with the Odroid, the local American Ameridroid group, they didn't have any way of making copies. Every individual one had to be genned by itself. And that was a pain.
Yeah, that was a very painful process. So yeah, you're bringing back all sorts of fun memories for me now that we're thinking through this. I blocked most of that stuff out, but I'm glad you remember it. But yeah,
it was the bad years.
Exactly. We had to overcome a few obstacles getting it this far. But yeah, we tried to do like a 32 gig memory card, thinking the main advantage was, if we're going to use this thing potentially down the road as some kind of maybe remote packet capture device or something like that, we'd want to have, some decent storage to be able to store those kind of files and stuff on. But yeah, the pain point was for imaging these things, since that's also the hard drive, is then we have to image 32 gigs of, an image file and be able to transfer that image file around and things like that. So tried to go a different direction where every time we installed this thing, it ran an install script and pulled down all the packages and things like that. And try to think this thing through a few different ways. But that wasn't great for a scale. It had some scalability issues with doing all that.
So there's 100 people or so in Budapest who can attest to that whole process. I mean, we got it to work. That there was a local drive, and if they got them to work and there's headless, they could go plug it in, and eventually all the packages came down and it rebooted and it worked, and then you had control over it. But now, using a smaller 8 gig drive, you can just do a straight up image copy, boom, done.
Yeah, exactly. That really was the ideal solution, right? I mean, that made it fix a lot of the issues, or overcame a lot of the challenges that we found. So yeah, using an 8 gigabyte memory card, actually even now with this new kind of project that we're working on here, actually found I can squeeze it down into a 4 gigabyte memory card and even make it more easier to move around. So I've kind of continued to fine tune that whole process to scale this thing.
So the next phase after the crazy headless process went, what if we get a screen? And then if you add a screen, and we kind of played with for a while a little 2-line LCD, which if all you needed was the IP address. So if you could get the 2-line LCD to show up and show, here's my IP address, then you could gain remote control. But better than that, and what we used last year's, all 3 WLPCs we used, LCD screen on top of the Odroid with an image, and that process went along much, much better. But we still had issues with cases. I mean, it's kind of a single board computer, and what do you mount it in, and then what do you power it, and you have to have power. So that worked well for a year, and we between the 3 WLPCs, I think we went through maybe 400 Odroids. But now, tell us a little bit about the NanoPi.
Cool, yeah. So that's going to be this year's WLPC kind of unveiling. We found a new hardware platform that's still the whole kind of Pi concept, but it's now built off this NanoPi kind of infrastructure, and it's called the Neo 2 is the board that we're using, and still has a gigabit Ethernet port on there, still capable of doing that 800, 900 plus megabit per second throughput. So still great for testing even things like, the latest and greatest 802.11ac APs, and still gives you all that functionality, but in an even smaller form factor. So this is a tiny little cube, and has a small LCD screen on there that's actually OLED based. So it's a nice, clean, crisp, text output on there that's nice and bright, fairly small but still easy to read, and has some buttons on there, and it gives us a lot of the same functionality that we had in the Odroid, but in an even smaller form factor, and in a more, I guess, it's a metal case on there, so a little more robust kind of case there to, be thrown in your bag and not have to worry about something crushing it or any problems down the road that way.
And it is not using eMMC.
Correct.
It's using just an SD card. But have you found any anything changed with that's worth worrying about?
Yeah, so one of the things that has been a problem in the past is these micro SD cards. Had some issues with these kind of consumer grade ones of some corruption issues if you didn't shut the unit down properly and you just disconnected the power while it was in the middle of maybe reading and writing some information. So with these NanoPis, they provide a professional, or I think they call it industrial micro SD card that has some read write verification type stuff, so protection type things built into it that should help prevent those kind of issues from occurring. And so far, I have not seen any of those kind of problems that we've seen in the past. So I'm hoping that this is going to be a good, reliable solution for long term.
Good. Well, let's since we went through the little history of the hardware, let's go back and do history of the services or software that was on your version of this this little test tool. So in the beginning, you just had iPerf, and iPerf 2 or 3.
So right off the bat, I think we were using. Yeah, that's a good question. I don't remember if it was iPerf 2 or 3. Probably would have been iPerf 2. This is way back when I first started with that kind of DDWRT, and that was one of the big problems. Is it only would support like iPerf 2. I couldn't put like the latest iPerf 3 version. I couldn't put on the ePerf, the Ekahau kind of iPerf 3 customized build of that for Wi-Fi.
A good little side note. What is ePerf and why do we need it?
Yeah, good question. So ePerf is Ekahau's own internal build of the iPerf 3 package. And what that does is allows us to do that same kind of throughput testing that you would do with iPerf 3, but using it in conjunction with like the Ekahau software for performing a site survey. The reason why you would want to use that over using iPerf 2 or iPerf 3 is due to the iPerf 3 software, the native code wasn't necessarily built specifically for Wi-Fi performance testing, and especially in the sense that we use it for of physically moving around a site, roaming between access points, potentially roaming off the network and getting to the point of being disconnected during a throughput test can crash that iPerf server. So the server wasn't really built for that resiliency of Wi-Fi and that kind of testing. So the ePerf kind of enhances that and is built specifically for that. So that way, if you do get disconnected during a throughput test, it will automatically kind of resume itself as soon as you're reassociated to the network and not crash in the process.
So you don't necessarily have to have an Ekahau ESS ePerf client. Any iPerf 3 client will work, right?
Yes and no. It's based off of the iPerf 3 code, but it's not identical. It doesn't have the full feature set of like iPerf 3. So it kind of depends on what you're testing. Certain things will work with it. iPerf 3 can be a little finicky depending on your clients and what versions of iPerf 3 they support.
So recommendation, if you're using a regular iPerf 3 client, use the iPerf 3 server.
Correct.
And if you're using Ekahau, use the ePerf server.
Yep, exactly. That's the recommendation. So that's why actually on the NanoPi and the Odroid, it's running both the native iPerf 3 code as well as the ePerf code, and they're just configured to run on two different ports. So that way you can run those tests as needed.
And so even with this little OLED display, or when we had the Odroids in the past, you can click a button and it shows up your current IP address. What are the things you can hit with that? Obviously, you can SSH into it and have control over the Linux box itself.
Yep.
In addition, what other ports is it listening on?
Yeah, good question. So it's got the iPerf 2. Let me think. So iPerf 2 is running on its native port. ePerf is running on the native iPerf 3 port. And then you also have iPerf 3. I don't want to say the wrong port. I think it's 5202 if I remember right. I think the default port is like 5201. So I incremented it by 1. And then you also have the ZAP protocol running on there, the ZAP package there made by Ruckus, which uses the SpeedFlex app, if anybody's familiar with that. That's normally running on Ruckus APs and controllers. This device can also run those types of throughput tests. So if you happen to not have a Ruckus network to test this thing on, you can plug this into any other vendor's equipment to do those SpeedFlex tests as well.
And if you don't have any clients at all,
if you don't have any clients to do the tests, you're saying?
Yeah, so it also runs
the web
HTML.
Yes, yeah, that's exactly. I thought that's where you're going. So yeah, one of the cool additions, and this was I think one of kind of the from WLPC, some of the suggestions was around the kind of enhancing this by adding a web server and doing some cool things with that. So one of the things we did was tried to emulate kind of that speedtest.net that everybody's so familiar with to test their Wi-Fi networks. And I kind of put that in quotes because we know as wireless engineers that you're not really testing the Wi-Fi network. You're testing a lot of other things when you're doing like a speedtest.net. But if we want to test just the Wi-Fi, we need to have kind of that closed loop. So we put a web server on the NanoPi, and that's running an HTML5 version of a speed test similar to speedtest.net. And you can run those upload and download speed tests on a closed loop to test the actual Wi-Fi throughput. So yeah, any client will obviously be able to do that, whether you're on an iPhone or an Android device or a Windows or a Mac. You just punch in the IP address of the NanoPi device and be able to do that speed test.
What I like it for is when your customers are, they say, well, show me this little test. Well, you just said, here, let's go take it. We plug it in, tell them the IP address. They hit it on their phone, laptop, tablet, whatever they've got, and they can run their own tests. And obviously it's only testing the wireless because we put it right directly behind the, wherever their AP is. So that was a handful of throughput testing. iPerf 1, iPerf 2, iPerf 3, ePerf, ZAP, and HTML5. So 5 different versions of doing throughput tests. What else can it do?
So a couple of things we can do besides just the throughput testing was we provide, it's got a USB port on there, so we can connect some stuff up to that. And one of the things we provide and have been providing is a Wi-Fi adapter, or USB-based Wi-Fi adapter, right? So same kind of just client wireless adapter that you can plug into your computer and use it to connect with networks. But with the Odroid and in the NanoPi running Linux, we can do some other cool things like some packet analysis type stuff. For one, we could use it as a client device, and we could take that Wi-Fi adapter and connect this thing to a wireless network that way as well, if we wanted to be able to access it over the Wi-Fi. But to be a little more useful, plug this thing into the wired connection and then utilize the wireless adapter as some type of monitoring device, right? So right now I'm actually, traveling, and I can actually connect, I've got a VPN into my house, and I can go and access that NanoPi that's in my house with a wireless adapter, and I can link up to Wi-Fi Explorer Pro and actually use that as a remote sensor to check the Wi-Fi in my house and see how the Wi-Fi is performing, see what other networks are, maybe overlapping with mine, and use that as, just like I would if I was in my house with Wi-Fi Explorer Pro running, but now be able to do that remotely from anywhere in the world. So that's one of the functions you could use the adapter for. I don't know if you want to comment on that at all, but I'll talk about another thing as well.
No, I think Adrian's tool is wonderful. We use it all the time. Those people have Macs and Wi-Fi. It's like the number one go-to tool. And then with his Pro edition, you get the ability to access a remote session. It could be another laptop that's talking back, but in this case, we just have this little NanoPi that does all those features. Wonderful thing. In addition, you have Kismet and Horst.
Yep.
Let's talk a little bit about those two options.
Cool. Yeah. So Kismet is, that one.
And again, for both these, you do need to have the Wi-Fi NIC.
Correct. Yep. So Kismet is, it's been around for quite a number of years. Most people, when they hear Kismet, they kind of think of this terminal, old school Linux kind of interface, right? Text-based kind of thing. Well, it's come a long way, and they've got a pretty cool now web-based version of Kismet that I've been toying around with. That's still in pretty active development, but it's come a long way and pretty useful from a wireless engineer standpoint, where we can put that adapter into a monitor mode, log into a web interface, and be able to see all sorts of information, not only about the APs in the environment, but the clients as well, and be able to get a lot of information, some statistics about packets and retries and things like that on an AP level as well as a client level, and be able to even associate some information about which APs are associated, or which clients are associated to which APs and on which channels, and how many, and then just get an overview of the spectrum of how many client devices are on each channel on the 2.4 and the 5 gigahertz bands.
So just to recap, it's your laptop would be connected to the access point that you're using. Behind the access point is the NanoPi hardwired into its Ethernet port, and then the NanoPi has a Wi-Fi NIC in its USB port, and Kismet's running on the NanoPi using the wireless NIC, and you're accessing it via the Ethernet. So you're not coming in on the same NIC that it's trying to do its work on.
Correct. Yep.
And Horst.
And Horst is an interesting one. So Horst has a couple of different, I guess the acronym means a couple of different things, but I always use the highly optimized radio scanning tool, analogy for that one, or the acronym for that one. But it's a pretty slick one. So that one is a terminal based. So you'll need to use something like an SSH SSH client to log into the NanoPi. And then from there, you can, again, put the adapter, or it will automatically put the adapter into a monitor mode. And then you can analyze all sorts of live packet analysis type stuff, right? So we can see things like, again, retries. We can see both AP and client information. We can filter down to a specific BSSID or a specific device MAC address, and we can see how that device is performing, what data rates that client is using, and what the retry percentages are. And again, this can all be done remote, right? So this thing could be deployed as a remote sensor on a network, and you could SSH into it and be able to see all sorts of statistics about the RF environment from a kind of a frame and packet analysis, live packet analysis level.
Very, very cool stuff. With a little teeny handheld, sit in your pocket, battery-operated device. Started out just to solve a problem that you had, and has come a long way. We definitely want to thank you for the amount of hard work you've done in building it. I remember, maybe 2 years ago when I first got started on this with you, I couldn't do any of the Linux stuff. So it's like, oh, Jerry, how do I do this? So it's come a long way. We'll be having a session of this. There's a deep dive that Jerry's doing with Scott McDermott on mobile testing, and you'll be able to, if you're at WLPC, you'll be able to see these little test tools. I think we probably will have them also available. Anyone's taking the advanced survey course with Blake, they'll be using these to do some throughput testing as well. So if you're interested, we'll put some links in the show notes about what they look like and where you can pick one up. And thank you very much, Jerry, for your time today.
Yeah, thanks, Keith. Thanks for all the support and making all this happen too. Like talking through all this, we've come a long ways in it, and definitely would not have made it this far with it without all your help and support and getting this happening.
Well, we'll just keep continuing on, making it better. Who knows what we're going to see next year? Maybe it'll be the size of a thumb drive. But this one is small, light, easy, and very robust. And we've learned this time around, we're not having the attendees assemble them at all. They will be pre-assembled, and they'll just working, and we'll treat it like a little baby appliance. Well, thanks for your time. Enjoy Florida, where it's warm, before you head back home to Wisconsin, where it's probably a little chilly right now.
Yes, it is. All right. Thanks very much, Keith.
Thanks.